trigonometry. Show that the equation can be expressed as. So the first thing we need is the secant definition. This is not in the MF19. So secant is actually 1 over cos, and tangent is actually sine over cos. So we can replace the secant with 1 over cos, replace the tangent with sine over cos, and then we multiply both sides by cos. So cos x times everything on the left times everything on the right. So when we multiply, we can cancel out, we have only root 5, and when we multiply, we cancel out, we have only sine. See, actually there is a sign here, somehow it's gone. So this is plus sine. Okay, this is actually plus sine x, and this is actually plus. Okay, so now we replace the 4. So yeah, we move things around here. We move this plus sine x to the right, so we have minus sine x now. So actually that was right, it is minus. Okay, so it is minus. After we move this plus sine x to the right, it is minus sine x. Okay, so everything's fine now. And now we use this expansion formula from the MF19. Cos plus, for cos plus, we have to use cos cos minus sine sine. So we use cos cos minus sine sine, expand r times everything, and we analyze now. So if we look at the variable cos x, on the left we have the coefficient 4, on the right we have r cos alpha. So 4 equals r cos alpha. And for the variable sine x, on the left there's nothing, so let's just say it's just 1. On the right we have r sine alpha, which means we have r sine alpha equals 1, and we can divide both equations. R divided by r cancel out. Sine over cos is again tangent, so we have the value of alpha using inverse tangent. And now to find the r, we use the fact that cos squared plus sine squared equals 1, so we just use the square of r cos and r sine, which is 4 squared plus 1 squared. And if we factor out the r squared, we have cos squared plus sine squared, which is 1, so that we can find the r. So the r in exact value, root 17, and the alpha is 14.04 in 2 dp. So we get what we need to find here. Alright, next part. So solve the equation. So previously we know that from this equation we can rearrange and use the double angle rule and so on. We get this is called the auxiliary angle method, basically. Okay, so using the auxiliary angle method, we get this is from the first part of the question. So since this is x and this is 2x, of course we're gonna have to modify, adjust a little. So instead of x, we have to use also 2x here. So here we use 2x, not x. Okay, it's got to be 2x also according to this question here. So we divide both sides by root 17, and now we find the base angle. So the base angle is using inverse cos. We have to make sure we have to use something positive here to get the base angle in quadrant 1. Now if we look at the domain in the question, it says from 0 to 180. Since the angle we are dealing with is not just x, we gotta modify the domain. So multiply by 2, and then plus 14.04 for 14.04. So this is the actual domain we are using here. Okay, so now we look at which quadrants we can use. So since we are talking about cos something equals something positive, we can only use the first quadrant or the fourth quadrant. So we can use the fourth quadrant, which is simply the base angle, and the fourth quadrant, which is the 360 minus base angle. Okay, so for the first quadrant, just the base angle, so this base angle, and for the fourth quadrant we have 360 minus base angle, so 360 minus 57.16, we get this fourth quadrant angle. Now we're looking for x, so we still have to subtract 14.04 from everything, and then we have to divide everything by 2, and we get the final answers. Right, there are 2 solutions. That's it. I'll see you again next time.